If you're here for data integration at scale, you're in the right room. My name is Dan Potter. I'm the Vice President of Product Marketing at Qlik. And joining me today is Glenn Wilkins from Vanguard.
Hi. Thank you for the introduction, Dan. I'm a senior architect at Vanguard, and I'll be telling you today about what we refer to as our data replication as a service platform, and it's built on Qlik Replicate.
And I'll be talking a little bit about SAP and how you unlock the value from SAP and do that at scale. So, quick show of hands. How many people here are Qlik customers, either data integration or analytics? Show of hands? Okay, thank you. How many of you are SAP customers or have SAP? Okay.
Yeah, how about on the mainframe side? How many mainframe customers here? Okay.
Awesome.
Awesome.
Okay, last question. How many of you have a Fitbit or some other step tracker and hit 10,000 so far today? I'm exhausted. So, awesome. I think you're going to like what we put together today. We're going to talk a little bit about what some of the considerations are for doing integration at scale. And we should have enough time at the end for Q&A. If not, we'll make ourselves available after. So let me dive right in. So those of you who are Qlik customers, again, thank you. You know who Qlik is. For those of you who are not, Qlik is an integration and analytics vendor. And our specialty is helping organizations unlock the value of data wherever it resides, moving it and shaping it in an automated fashion, and delivering not just insights, but action from that data. And we're no stranger to the AWS environment, the AWS ecosystem. We've been a long-term partner of AWS, advanced technology partner, a wide variety of different competencies, and a large number of customers. We tend to focus on the most difficult problems in the AWS ecosystem when it comes to data integration. And SAP and mainframe are two of the more challenging sources, so we're going to drill down and talk about that today. First, when it comes to scale, what are some of the key considerations around scale? And we think about it in two different ways. From a systems perspective, you need to think about things like throughput. How much data do I need to move across the wire, and how do I do this in a very efficient way? How do I do this in low latency? More and more real-time data is required not only for operational tasks, but for analytics tasks as well. How do I make sure that I have high availability in what I'm doing? And how do I make sure that it's not disruptive? What we're doing on the integration side is not disruptive to those core transaction processing systems that are running the business. So those are some of the things we'll talk about from a systems perspective. Glenn's going to touch on a lot of those very topics. The other thing to consider is, how do you scale your team? How do you scale the data engineering practice, the people? And how do you apply this technology to support a growing set of diverse business use cases and data architectures and cloud and hybrid deployment solutions? How do I not just move the data, but transform this data to solving those different business challenges? How do I handle things like governance, regulatory requirements in a more automated fashion? And how do I deal with the limited resources and, more importantly, what we see is limited expertise? Right? How do I solve these problems in a more automated way? So those are some of the considerations that we'll touch upon. What's driving all of this? There's kind of three key drivers that we've seen. The first one is around cloud application development. This is really the Vanguard story, and Glenn's got a great story about how you encapsulate and take functions on-prem from a mainframe and start to deliver and synchronize that data in real time, take a microservices approach and how you do that, and build out new applications on top of that transactionally supported data. The other big one is data warehouse modernization. This is Redshift, this is Snowflake, this is others. How do we take that data, move that data, make it analytics ready, and change the processes by which people had been doing traditional data warehouses like the Teradatas and the Netezas of the world? How do you automate both the ingestion of that data, the creation, the full life cycle, the creation of the warehouse, handling the frequently changed data, and take a model-driven approach to automate the creation of that warehouse? And in a similar vein, how do you do that same thing with data lakes? So When you think about next generation data lakes supporting different formats, creating analytics-ready structures in an automated fashion, handling things like real-time streaming and streaming services like Kafka or Kinesis. So these are three of the big drivers as we see it. Again, like most of you, you probably have all different types of heterogeneous data that need to feed into this. And this is where integration comes in, right? Integration is much more than just connectivity, right? It starts with connectivity and ingestion, but that's not the be-all and end-all. So you need to move it in a more real-time, low-latency way. We'll talk about the role of change data capture, data warehouse and data lake automation, a no-code way, a model-driven approach to creating automated structures, transforming that data for fit-for-purpose use cases, and how do you handle things like SaaS applications or SaaS databases from an API level and do things like workflow automation and business process automation from an app-to-app perspective. So this is what Qlik Data Integration does. And in the context of AWS, lots of different targets, right? You've got S3, object stores, you've got databases, you've got data warehouses and data lakes, you've got streaming services like Kinesis. So you've got lots of sources, lots of targets, and many of you probably have some of these others in the ecosystem as well, the Databricks of the world, Snowflakes, Confluent for streaming. So to do this well, you need to support a wide variety of sources and targets. And that's what we do. Now, with respect to the data sources, we're going to focus on the bottom on two, on SAP and mainframe, and why. I kind of teed this a little, but I'll stop with the teasing and say, look at some of this data for mainframe and SAP. The mainframe is not dead, right? If you look at business critical transaction processing in large organizations in many industries, it's still being done on a mainframe. 90% of credit card transactions are done on a mainframe. Mainframe's not going away. More and more processes is being moved to the cloud in intelligent ways, but that core transaction processing in the mainframe is largely staying on premise. SAP is another good one. Many of you said you had SAP, and you know that a lot of business transactions touch an SAP system. So according to SAP, 77% of all business transactions go through SAP. So that's why we wanted to focus on SAP and mainframe. Obviously, there's a lot of different sources. A lot of the approaches that we're talking about today will also be applicable. But we're going to start with the mainframe, and Glenn's going to share his story. And a little bit of introduction from my context in Vanguard. Vanguard's been a great example of the power of what you can do with data integration in the mainframe. They've also been a wonderful partner of ours. A lot of the developments that Glenn's going to talk about really came working with Vanguard, and you guys pushed us a lot in a lot of the scalability areas, and we thank you for that. And I think what you'll find is a really robust set of capabilities on the mainframe. So, Glenn?
Okay, good afternoon, everyone, and thanks, Dan. I'm going to start out with a very brief company background and our history with mainframe, and then I'm going to elaborate a bit on our enterprise technology strategy and how Qlik Replicate has become a key enabler for our cloud modernization program. And then I'll dive into the main topic of discussion for today, which is going to be our data replication platform. And I'm going to drill down into one particular feature of Qlik Replicate in particular that has allowed it to become more scalable for us on an enterprise level. Now, my own particular background, I've worked for in over 20 years in mainframe, both applications and systems development, many conversions along the way, DOS to MVS, vSAM to DB2. But in 2017, I did a bit of a career pivot. I went all in on AWS infrastructure and cloud data architecture. Along the way, I picked up an AWS certification as a professional architect. And I've been attending reInvent sessions since 2018. The sessions that I really walked away with the most value and benefit from were ones that told me and described strategy for cloud modernization that were relevant to my use case, and also presented me with reference architectures or blueprints on how I could get it done, things that I could consider and could take back to my organization. And those are some of the things that I'm going to try to deliver and present to you today. I'm going to tell you a little bit about our adoption story at Vanguard in terms of cloud modernization. Vanguard was founded in 1975. And it was back around that time when we began our business systems development on mainframe computing platforms, OS 370s, 390s, ZOS today. So during across the 1980s, 1990s, or early 2000, we developed not just millions of lines of code, but probably something on the order of 60 to 70 millions of lines of code in COBOL-based programs running on the mainframe. I believe we had up to 14,000 batch jobs running on ZOS. So that together with Java web-based applications that were running on Linux. So over the course of time, across many years, we developed what you would probably consider a classical monolithic type of application. So as you know, with monoliths, some of the downsides of them tend to be complexity. As time goes by, the monolith gets larger and larger. It takes longer periods of time to move new business functionality to production. Teams are slowed down by that complexity. And then also from a deployment standpoint, because of the dependencies between teams, with a shared database and that large monolith, it required a lot of regression testing. And as a result, for many years, we were able to only schedule and implement 4 production elevations per year. So that's only 4 times per year we're able to move new business functionality to production. So, it was very, very obvious to us that we were being constrained by this type of legacy monolithic technology, and we had a strong thirst and desire to move to a more distributed, cloud-based microservice type of architecture. So, approximately 2015, 2016 time period, we began to go through an evolution of sorts within our organization. We wanted to adopt new ways of working. We wanted to reorganize our business and our application development teams into product families and product teams so that they could be more independent. And with the goal of achieving greater speed, reliability, and lower cost. And then along with this strategy, the data is a key component, a differentiator of it. Along with our strategy, we wanted to move our data, pretty much all of our data, to the cloud to take advantage of modern cloud analytics services and databases. Now, so we've made a couple of big decisions already. One was we wanted to modernize our business portfolio to the cloud. The second big decision you need to make as a cloud provider, well, that's going to be AWS. And now, shortly behind that, you have to choose a migration strategy or a modernization strategy. So there's quite a few different patterns out there, and I'm sure you've heard of a number of them. The 5 Rs, for example: rehost, refactor, replatform. Now, one thing that we didn't want to do is we didn't want to lift and shift our monolithic application up to the cloud and take all of that technical debt along with it. So we chose the the strangler fig pattern. And there's 5 milestones along the way. But essentially, the strangler pattern allows us to, it's an iterative approach. It allows us to realize value early and doesn't carry with it, the high risk and the length of time that it would with lift and shift. So we wanted to refactor our monolith into distributed microservices. A good best practice there is a single database per service. And the first milestone is making your data available in the cloud, migrating it up from the mainframe. That isn't, with ZOS, it's a relatively proprietary type of data structure that needs to be transformed to a more modern cloud data store. So early on, you need to select a CDC-based product to support that. Now, CDC stands for Change Data Capture. And one of the reasons I call that out, as we were going through our selection process for a data migration product to utilize, we wanted one that used CDC-based technology. So there's some other forms of migration which involve direct querying or selecting directly from the physical table. The big downside with that is, if you're retrieving directly from the table, you're competing with the business applications, that are also retrieving from the same data. So with Change Data Capture, it's retrieving all of the database activity from the transaction log, which is decoupled. It's an asynchronous process from the data store. So you can retrieve from there, more efficiently without disturbing the production applications. So milestone 1, moving your data to the cloud with a replication platform. And I'm going to have a lot more details coming up on that. And then as you make progress through this strategy, you enable both reads and writes in the cloud. You continue to chip away at your on-prem monolith, strangling those legacy services, gradually reducing MIPS as you go along, improving cost, till eventually you can begin to depreciate or retire some of those on-prem services, and AWS now becomes your gold copy. Now, at Vanguard, this is a multi-year effort. We're probably about, I would say, 50% there at this period of time. Now, before I get into our describing and giving you some of the details of our replication service, here's some statistics just to give you an idea of the current workloads on our mainframe. So our average daily volume is about 400 million transactions today. That's the overall workload that we're replicating to the cloud. And we currently have 18 servers, Qlik replicate servers in production. So we've tended to segment or divide up our servers according to line of business. We have multiple lines of business within Vanguard. And then within the lines of business, we also like to separate them out to some extent by product family. In some cases, we divide them up by workload. So we may have certain workloads which are performing replication for operational use cases, and separate servers for workloads supplying analytical workloads. And we have 3 primary target endpoints that we replicate to. S3 for analytics, Kinesis, which is really a staging area for DynamoDB, and then Postgres Aurora. We have 3 primary reference architectures, and I'm going to provide you with a little bit more detail on each of those. Now for kind of the heart of our system, data replication as a service. I refer to it as a golden path platform. So what I mean by golden path is that it makes it easy for our application teams that are adopting replication, easy for them to do the right thing and difficult for them to do the wrong thing. Now, one of our main platform objectives up front is to provide DevOps capabilities. So it's built upon infrastructure as code. It's enabled in a CI/CD pipeline so that application teams can adopt it easily and quickly. We also want our replication platform to have low latency. We target 2 seconds and under for source to target replication. We want our platform to have high availability. You know, we're a financial institution. We can't afford any downtime, particularly during the business day. And we want our business to have very high confidence in the data quality. All platforms that we establish within our chief technology organization also have observability. So in the case something does go awry, we want our support teams to receive notifications. And then within the last year or two, we've also been working on support for multi-region. We have applications at Vanguard, which span multiple regions. They may be active-active, or in some cases active-passive, but we want our replication platform to be able to provide the data to multiple regions. Now, the infrastructure automation, this is really kind of the heart of our service. Building the infrastructure as code. So if you were to receive the binaries for the Qlik replicate product and to go through all the processes to set up and install that manually, deploying your servers, setting up the storage, the Windows server, performing all those tasks manually, could take days or even weeks. So we use AWS CloudFormation along with custom resources developed in Lambda to implement our infrastructure code. Now, within our reference architecture and that infrastructure as code, some of the things that this will perform within the CloudFormation, first of all, it will standardize the security architecture. So across, between on-prem and our AWS data stores, we have an architecture where there is encryption in flight, encryption in transit, encryption at rest from end to end. Our infrastructure as code will deploy the EC2 instances. It will configure their block storage volumes. We also use FSx Windows storage that are also attached to the servers. Our infrastructure as code will perform a lot of things, essentially automatically and transparently for our application teams. It will set up the security groups, the DNS configuration for the Qlik replicate UI, balancers. It will install the product, DB2 drivers and certificates. And we also set up and install an automated script on the Qlik replicate server, which will automatically handle endpoint authentication. So it's integrated with AWS Secrets Manager and directory services. Establishing all of this in CloudFormation with an infrastructure as code, an application development team, can onboard. They can adopt replication for their databases and for their applications literally within a couple of hours. All they need to do is to supply the CloudFormation with a small set of parameters, such as the AWS account that they want to deploy to, an email address that can be used for alerting and notification, and an application ID, which has been given the permissions to retrieve data from the specific tables on the mainframe for their particular application. Now, there's one other very important capability that our infrastructure as code also supports, and that's the availability infrastructure. So everything that I just described, that entire infrastructure with the EC2 and all of the attached components, we actually deploy 2 instances of that. We deploy a second instance of that infrastructure in a second availability zone. And that second instance will act as a warm standby. So in the event that any type of disruption occurs to the primary server, a power outage or whatever the case may be, that will trigger a CloudWatch event, which will trigger a Lambda. The Lambda will start the replication tasks on the standby server exactly where the replication left off on the primary. And that capability, which provides for 0 data loss, is enabled by AWS FSx storage. So with FSx Windows storage, it supports synchronous cross availability, mirroring of the data. So the standby server has access to all of the metadata and staging information that the primary server has. And within that metadata, the Qlik replicate stores the last committed LSN, the last committed log sequence number, so that when the tasks are started on the standby server, they pick up at the specific point in the transaction log where the primary server left off. Now, we have 18 servers in production. It's not, in reality, it's not really that frequent that we actually utilize the failover situation in production. Across our 18 servers, we may have 2 or 3 events across a full year's time period. Now, so that's essentially our data replication service. It's deployed the product. It's instantiated, it's running, and it's fully available on the cloud. So now the application team can go into the user interface and they can configure their replication tasks. Now, the first of 3 popular reference architectures that we utilize at Vanguard is replicating to RDS Aurora. So if the applications team, they've been using a relational database on-prem, they're basically happy with that, or they want to continue having a relational database in the cloud as well. We've chosen Amazon Aurora as the target database in the cloud. It's fairly compatible with DB2 in the regard that they're both relational models, and the replicate product makes it fairly transparent in the process of replicating that data. When the applications team sets up a replication task, they define the source endpoint, the source tables that they'll be replicating. They specify the endpoint location of their target database, and then they start the replication task. The first thing that the replication task does is it checks the catalog tables within DB2. It retrieves the data definition language and creates and establishes those same tables on the target endpoint. As the replication begins, it starts out by doing a full load. At the completion of the full load, it goes immediately into CDC processing and captures all the update activity going forward. Now, I've seen DB2 tables on the order of some of our smaller tables with about 2 million or so rows, be able to do a full load to Aurora in about 1.5 minutes. I've seen some of our other tables, 30 million rows, be able to perform a full load in about 15 minutes. Now this is, there's one particular feature of Replicate that I mentioned earlier. I wanted to give you a little bit more technical information on, and that's log streaming. So this is a feature which came out with version 6 a couple years ago. And the big difference between log streaming and the way replication was previously designed in earlier releases, as well as what we see in other replication products, is that, you know, as we're performing replication, you know, we have many tasks on the server. Each task is replicating to a different target endpoint. And in the past, each task had a separate connection to the database. And you know, what we found was, even though that we're retrieving data from the transaction log, which is fairly efficient, most of our servers had, you know, anywhere between 10 tasks, some had 50. We even had servers going up to 100 tasks running on an individual server. So when you have that many connections going back to the database, you know, eventually that is going to be expensive CPU and MIPS wise. So early on in our program, you know, initially we started with about 2 or 3 servers. On the mainframe, you define a resource group that's allocated with a particular number of MIPS for the capacity that you want to allocate towards replication. And what we were finding was earlier on, when we had all these many connections back to the source database, even with just a couple of servers, you know, we were up kind of maxing out already on the mainframe. So we weren't really sure at that point, you know, just how scalable the product, you know, was going to be for us. But it was around that time that Qlik Replicate announced log streaming. So now all of the this enabled a single stream from the transaction log up to the Qlik Replicate server in the cloud. From the Replicate server, now you have individual tasks from there going out to the target destinations. And I captured some statistics here. So here in the 2 graphs on the left, I'm comparing the MIPS utilization for 2 different workloads running in the cloud. Now, the blue line represents the MIPS consumption by a non-log streaming server. The orange line, you know, which you see running along the bottom, was that same workload with the new version 6 or version 7 or Qlik Replicate with log streaming. So those are 2 different workloads there that had different activity during the day, but the non-log streaming was taking several hundred MIPS per server, while as the server utilizing log stream, as you can see there, it's in single-digit MIPS. This was essentially a game changer for us, because at this point, you know, it provided us with a lot more freedom and flexibility. Some of our product families, they could now allocate their own servers individually for their product family, which gave them a lot of flexibility, you know, especially within the test and QA environments. You know, they could do elevations, or they could take their servers up and down independently of other teams within the organization. One other thing I just wanted to point out on the mainframe side. You know, I had mentioned earlier where retrieving from the transaction log is more efficient than going to the physical table directly. The other thing I wanted to mention is on our transaction log on Z, we also have a 2 gigabyte buffer. So the most recent CDC activity is going into that buffer, and that's where we're retrieving it from. So that also allows us to have very low latency, close to real time replication. The other thing I wanted to mention was high availability on the mainframe. Now, earlier I mentioned how we had high availability in the cloud, where we had a failover process which goes from primary to secondary with zero data loss. Actually, we have a similar concept set up on the mainframe. We have the Attunity agent, which gets installed on the mainframe, running in two separate DB2 regions. And those regions are on separate LPARs. So we have multiple mainframe CPUs. They're configured in a sysplex. So if any one of our DB2 regions encounters an issue, it automatically fails over to the replication agent in the other region, which can also be on the other LPAR. So that not only provided us with high availability during a normal week, it also helped us out with IPLs. If you're a mainframe shop, there's probably a good chance that you perform IPLs during a window on the weekend. Now, in the past, before having the multiple agents on the mainframe, we had to actually take our systems of engagement, our website down during that period of time. But now, the fact that we have the agent on two separate LPARs, it allows us to continue elevation through IPL windows. When one mainframe is shut down, the replication is active on the alternate mainframe unit. Now, reference architecture number two, and we use this one for analytics. We replicate our DB2 databases to S3. S3 is a staging area where it's consumed by AWS EMR and then moved into the data lake from there. So what I've observed, between our replication to whether it be to Aurora or S3, I'm going to describe Kinesis in a moment. Each one of those has roughly the same latency. S3 and Aurora are particularly very easy to implement. And then our third reference architecture is for our application teams that are interested in taking advantage of a NoSQL database in the cloud, such as DynamoDB. Now, some of our application teams that are developing Java applications, the way they set up their object-oriented classes and methods, they prefer the schemaless type of structure and NoSQL that DynamoDB provides, along with its extremely low latency and scalability as well. DynamoDB also provides global tables, which help our application teams a lot to support multi-region. So this is a very popular reference architecture to replicate from a relational database to NoSQL. Now, you'll notice here that we're performing our replication to a Kinesis stream endpoint. And from there, we ingest the data before it goes into DynamoDB. There's a lot of transformation that occurs between a relational and NoSQL. So the Lambda performs the denormalization. It maps the relational tables and columns. Typically, we have anywhere from 2 to 10 relational tables that map to a single table item in Dynamo. Now, Kinesis is not a database. When you're replicating to relational databases such as RDS or Postgres Aurora, Qlik Replicate maintains the transactional integrity as it's storing the data into the database. So you have a unit of work that was just committed on the mainframe. You get that same integrity with the unit of work when it's saved into Aurora. Now with Kinesis, that's a messaging infrastructure. So when the data's landed into Kinesis, it's just kind of landed in there as a sequence of records. So one of the things that we noticed, we were actually, I think the first adopter of Kinesis with Qlik. We've had a very strong partnership with Qlik over the years, and they actually began supporting Kinesis for us around the 2018, 2019 timeframe. And so we were basically the very first customer to utilize Kinesis as a target endpoint. And one of the things that we noticed was, as data is being written to the Kinesis infrastructure by the Kinesis API, it's written there in batches of 500 records within a batch. And then the Lambda is triggered, and then it operates on each batch. Now, we sometimes had units of work on the mainframe that may span a batch. So what we noticed early on in our testing, sometimes we had some data issues there, as a result of units of work spanning batches, and getting data out of order as it was Dynamo. So we worked with, we set up a session with Qlik to discuss this, and within, it was probably just within a couple of months, they delivered a new release to us which supported additional data within the Kinesis envelope that's kind of wrapped around the replicated data, with some additional metadata in there that indicated to us the number of records that were involved in the unit of work. There was also an end of transaction flag. So this enabled us to when we had this situation, it allowed us to park the data in a staging area in DynamoDB, retrieve it from there, and it allowed us to maintain that transactional integrity as we saved the data to Dynamo. So this was a process which, we coded it and tested it, fine-tuned it, within a Lambda, and then once the solution was proved out, we were able to incorporate that same solution across. We use this reference architecture for close to 200 DynamoDB endpoints. Enhanced fan-out, I had mentioned how we replicate to Kinesis. You can also replicate your data to another messaging infrastructure, Kafka, MSK or Confluent as well. Now, I had mentioned earlier how sometimes we separate our workloads, operational on one workload, analytics on another. So now, the apparent thing with that is in some cases we're replicating the same data, same set of DB2 data twice, for separate servers. We started out with that approach from the beginning. There is another pattern where if you replicate to Kinesis or Kafka, you could have a fan-out pattern, which is taking the same data and have separate tasks which go to Aurora, S3, and Dynamo. So I just wanted to mention that reference architecture here. It's one that we found interesting at Vanguard. We haven't quite adopted it, but it could be something to give consideration for. And actually, if you're using Kafka as a target endpoint, you may not even need a Lambda to perform your transformation, because some implementations of Kafka, they come with, there are sync connectors available to AWS endpoints. There's also KSQL, which is capable of performing some level of transformation. So with a Kafka implementation, it's possible you might not even need to develop code within a Lambda to perform the denormalization and transformation. Data quality, our data quality, has been excellent with the product over the course of the years. Now, when you're going from relational to NoSQL, and that transformation that I described there, that has varying degrees of complexity. So that's where, when you're performing that level of replication and transformation to NoSQL, you might consider implementing some type of data quality process to verify the data, just to ensure you don't have any discrepancies. So we have a couple different techniques that we use to data quality. The one that's displayed here takes CRUD activity, the number of inserts, updates, and deletes that are performed over a period of time. It sends that up to the cloud, and we do a comparison between what we received, what we stored on the target endpoint, and what we stored directly on the source database. If there's any type of a discrepancy there, it would create a notification. Multi-region architecture. This is something we've been working on over the course of the past year or so. Essentially, what it comes down to, that same type of architecture pattern that I described for high availability within a region, we took essentially that same type of design philosophy and built it for multi-regions. So to support multi-region, we deploy a set of replicate servers in our secondary region. And then in a case that there's an outage, they're very infrequent in AWS, but over the course of the past 10 years, there have been a few outages of a few hours or a day or more. So in the event that anything of that nature occurs, we can switch our replication. We have a toggle. Now, within region high availability, that failover process was automatic. It's transparent. It's well tested. It could transpire during the middle of the night. No one a notification would go out, but it would actually be very transparent. With our multi-region architecture, that's a manual process. Multi-region failovers, they're very infrequent. The scenarios vary quite a bit. So, we don't feel too good about having that be an automated process just because of the, certain particular scenario that might be involved. So it's a manual switch, but we're able to fail over to a secondary region, and again, pick up with the replication exactly where we left off. And then one of the things that helps out with that is AWS FSx storage. One of the newer versions of that, FSx ONTAP. It's ONTAP supports Windows, and AWS FSx ONTAP has synchronization across regions. It's an asynchronous form of replication across regions, and it keeps the servers in sync within a couple of seconds. So it works out very well for our multi-region use case. And then, kind of lastly, everything I described here with our data replication as a service and our infrastructure as a code, we want our teams to be self-provisioned. We want it to be easy to adopt. So we maintain a client information hub. Basically, it's a set of documentation on how to get started, implementation hours. We hold office hours once a week, which is basically an hour once a week where we have collaborate with our application teams on any questions that they may have. And then lastly, I wanted to give credit to our DRAS team back at home at Vanguard. We have Randy, who's the project manager, Rajiv, Paranthi, and Raghu, they're architects. Now, these are folks which have contributed, they may not be on the team today, but they've contributed substantially to it at some point. We also have Paranthi, Brendan, and Arun as engineers, and Mackenzie Miller, a technical lead. So I just wanted to give a shout out to those folks for the great job that they've done in providing this golden platform service to all of our 100+ application development teams at Vanguard. I guess I'll turn it over back to you, Dan.
Thank you, Glenn. And there's your master class on performance and scale and availability for mainframe. I love the fact that he added the team on here, because it's not just about the technology, it's about the team. And I'm going to touch on a little bit. I don't have a lot of time, but I'm going to try to do this as best justice that I can. Many of you said you had SAP. Your business probably runs on SAP, right? So I don't have to tell you how important SAP is to most organizations that are running SAP. I can tell you, if you haven't tried to access and leverage this data, there are lots of challenges with doing this, right? Proprietary data formats, really difficult to understand metadata, tough to build a data model. License restrictions may be the biggest impediment for some of you, the old runtime versus enterprise challenge, and that sometimes dictates the architecture, and performance and latency. If you're trying to do analytics against a transaction processing system, that's a bad idea. So this isn't a knock on SAP or SAP HANA. This is there's different architectures to support different use cases. And I'm going to share with you a story today that's an interesting one, and I'll do it quickly. ABB. ABB, if you don't know, they've been around for 130 years. They're a $26 billion company based in Zurich. They do robotics. They do process-centric business process optimization. Really interesting company, over 100,000 employees. They've got 36 SAP systems around the globe, supporting 4 major units of business, so highly diverse. And in 2020, the senior management team said, we're going to become a data-driven company. So the team had to figure out how to do this, and how to do this quickly, and how to do this well. High-level architecture, Qlik fits in a lot of different places. For them, this was really an end-to-end data integration to analytics implementation, right? So we helped them unlock the data from SAP, from some of that plant data, those operational IoT systems, files, moved it into their data management platform. So we helped them move that data into a target environment, which is Snowflake. So for them, Snowflake is both their data lake and their data warehouse. So again, helping them ingest this data, transform this data, make it analytics ready, catalog this data, and provide it to business users using a wide range of different analytics tools. QlikSense being one of them, Power BI, data science tools, and others. And this is very typical. Most enterprises have a lot of different tools and technologies. From an integration perspective, we need to be open agnostic and say, in what shape do you want this data? How do you want this data? When and where? And tell us how you want to consume it. So cutting to the chase, their CDAO, Babu, great guy. This is a slide that I stole from him. He presented at one of our user conferences, and I think this really helps paint the picture on the scale of some of the things that they do. Again, this was the first cloud-based data warehouse and data lake that they built. 37 SAP systems continuously feeding. These are large, 550 tables on average. They've got 10 years history in the data lake, in some cases up to 20 years, 63 terabytes of data and growing every single day. It's continuously being updated. 250 million transactions get processed a day, so that's all change data capture and how that data moves. 2-second query response. Anybody want to guess how long it took them to integrate these 37 SAP systems? More than a year? less than a year, 7 months. So SAP is really hard. We've got a way to help crack SAP systems in a really powerful way, and that's a great proof point. So we help you unlock the value by making the data accessible and available and easy to understand, helping you with the analytics if you need it, and streamlining SAP desk data management. And especially as many of you, if you have SAP, you're in the process, I'm sure, of moving to HANA or figuring out how you're going to move to HANA. Test data management kind of helps that process in a very significant way. The first part of SAP is, how do I unlock this data? And this is where all of that real-time data replication, all the things Glenn talked about, the goodness of change data capture, log-based change data capture applies to SAP. And I'm going to talk about how we can get at SAP in different ways, but unlocking the data is the first step, automating the creation and the transformation to make analytics-ready data sets available in a data lake or a warehouse, and in some cases, moving external data into HANA. If HANA and BW is the system that you're going to be building analytics off of, we can help integrate into that as well. This is the money slide. Real-time data replication, we do it in a variety of different ways. And I talked about some of the challenges from a licensing perspective. If you have a runtime license, you can only get at SAP data through the application level. You can't go directly to the database. If you have an enterprise license, you can go directly to the database. So we've got different methods in which we extract and make data available from SAP. The application extractor is going through the application layer. Database triggers, database logs, that's the most highly preferred way to get the data. So again, we support different ways to support both the licensing restrictions, but also what the real requirements are. So using extractor, it may be 15 to 20 minute latency, whereas doing it from the database side, it can be 2 seconds. And again, I'm sorry, I'm going through this pretty quick. There's a lot to talk about SAP, but I wanted to make sure we talked about this because it's new. SAP ODP, so operational data provisioning or operational data queuing. This is a new framework introduced, relatively new framework introduced by SAP. This is a way that you can get at CDS and HANA views very easily. The compression is significant. What we've seen internally is 90-95% compression, so that really significantly improves performance. You got greater visibility, observability, what's happening, where it's getting extracted to. And again, this is all supported through a runtime license. So this is a really interesting way in which you can do that. And how we've architected to support ODP is kind of bypassing OData, which is kind of a direction that SAP is instructing, and we view it more as a source for replicate. So taking ODP and the queues, and the queues give you the deltas, and using that as a source for replicate. So you get all the goodness of replicate. So all the things we talked about, the target schema creation, preserving the data types, doing filtering, doing transformation, doing scheduling, it's all done through Qlik Replicate. And again, any and all targets that we support, you can move that data from ODP and ODQ directly into those targets. The other piece, and this is a lot to sink in, but this is really important. So automating the data pipeline is about the data and it's about the transformation. So Qlik Cloud Data Integration is a new offering from us. We announced it a month ago. It's a platform as a service offering that enables you to do this end-to-end integration. So the first step is that CDC-based data movement and replication, but that automated models and transformation for SAP, this is a gold mine. Because what we do is we've got a full set of templates and models pre-built for SAP. And all of this now is available in Qlik Cloud, in addition to the templates for predefined analytic applications. And there are 3 that are out of the box. And we announced these today at the show with Amazon. So order to cash, financials, and inventory management are the 3 areas where we provide the data extractors and all the extraction tasks to perform that. The data the business data models. So all of those models and the business glossary has all been predefined, and the analytics application templates. So you can go from zero to hero in SAP extraordinarily quickly. So this is, the example of the order to cash SAP Solution Accelerator. This is available when you're a Qlik customer and you're using data integration and analytics. This is available to you out of the box. And again, this is going to significantly help provide the scalability to your data engineering team in delivering business value to users. I'm out of time, but I wanted to give you a few final thoughts. This is where we started, talking about systems and data engineering scalability. The things I hope that you got from this, from a systems perspective, how you go about getting that data and change data capture and the extract once, use many, and transactional units of work. There's a lot of unique things that we do to help give you that scalability from a systems perspective. As a data engineering team, automation is key. So how do you automate every step from ingestion to a warehouse to a lake, push down SQL into those modern platforms, automatically govern and catalog this, the solution accelerators we just talked about. Again, scalability it's hard to achieve, but you have to get there if you're going to be successful in moving to the cloud. So sorry I blew through that pretty quickly, but I'm hopeful that you got something out of it on the SAP side. I know I got a lot on the mainframe side, which was awesome. So Glenn, thank you very much for helping me present today. Stop by our booth if you'd like to learn more, if you'd like to see this in action. And I'd like to thank all of you very much for joining us today. So thank you very much.